In this demonstration, we will go through a gas pipeline monitoring example for exploration and production industry. The demonstration process contains 4 gas offshore platforms and gas producing facilities onshore. The produced gas with different flow and qualities from the platforms are combined and transported to the gas plant via a 138 kilometers long pipeline under the seabed. A number of operation challenges are faced by the operator. The VOP index of the delivered gas to the gas plant must be maintained between 50 and 53 megajoules per normal cubic meters. Otherwise, the gas will not be processed in the gas plant and have to be disposed elsewhere. Hydrocarbons, water, and chemical additives accumulate inside pipelines and thus cause flow assurance problems and eventually plant trips. Condensate accumulation inside pipeline will also lead to a more peaking operation and thus reduce the low production cycle. To address these challenges, an online pipeline monitoring solution is deployed using various AspenTech products. An offline dynamic model is developed in Aspen HYSYS to predict the VOP index of a natural gas into a gas plant in next 9 hours. Estimate total condensate holds up so it does not exceed the catcher capacity. Predict hydrate formation in the delivered gas. Estimate the pressure and the temperature profiles along the pipelines at the various locations. Once the model is validated offline with the historical plant data, it is connected to real-time plant data in IP21 database and scheduled to run at specified intervals. The system is to provide real-time guidance to a plant operator on the current plant performance as well as predicting the performance into the future, so the plant operator will have a lead time to respond to the changes in the plant operation. The proposed solution architecture is illustrated on the left-hand side of the slides. The model is scheduled to run every 15 minutes. At the beginning of each cycle, Aspen HYSYS model is updated with real-time plant measurements pulled from an IP21 database via Aspen Online. The raw data is then conditioned before they are pushed into the HYSYS model. It takes about 10 minutes to run HYSYS dynamic model to predict the pipeline performance 9 hours into the future. As soon as the model converged, IP21 tags are updated from the selected model results via Aspen Online, and so are the online operator interfaces developed in Aspen One Process Explorer in this demo. First, let's look at the HYSYS model used for the demo. On the left-hand side, 4 material streams representing the gas produced from 4 corresponding platforms are routed to an Aspen hydraulic subflow sheet. Inside the subflow sheet, 138 kilometer long pipelines is modeled using a 3 Aspen hydraulic pipeline segment block. These pipeline segments are divided by mixer blocks, which are used to introduce a gas stream at various locations along the pipeline. Within each pipeline segment block, multiple segments are created to define the pipeline geometry and elevation changes. Heat transfer set is specified as a sub-C. The outlet gas from the pipelines are compressed. A hydrate formation utilities is attached to the final delivered gas stream to evaluate the possibility of a hydrate formation. Once the offline model is developed and validated, an Aspen Online project is created and configured to connect HYSYS model to IP21 database and run model in every 15 minutes. For dynamic model, user is able to specify look-ahead interval, in this case 540 minutes, which is equivalent to 9 hours. User must bring in plant measurement tags from IP21 using identical names, and specify data conditioning rules for those tags whose value and quality may be questionable. Typical data conditioning algorithms include averaging, validity check with lower and upper bound, and overriding with the default values. In many situations, steady-state detection on specified key measurements must be carried out to ensure that plant operation reaches steady state. For this demo, steady-state detection is not included. Once the tags are defined, condition plant measurements must be pushed to the model variables by mapping the model variable with the tags as a source. The selected model results could be mapped to the output tags, which are stored in the IP21 database. These results will be then visualized on the operator interface. In this demo, the key plant measurements for model inputs are gas temperature, model flow, and compositions from gas platforms. The pressure measurements at the inlet of gas plant are also available and taken as model inputs. The primary model outputs are pipeline temperature, pressure, and condensate holdup profiles along the pipe distance. A few KPIs such as the gas volume index at the current conditions, a total condensate holdup, and hydrate formations are also exported as outputs. Finally, the model results are visualized in the web-based graphical interfaces developed in Aspen1 Process Explorer. Main screen illustrates processes with the key operating conditions. 4 gas platforms producing a gas and transported to the onshore gas plant for further processing. For each gas platform, measured flow and pressures are shown in meter column in black, while the estimated delivered pressure and volume index are displayed in purple in the model column on the screen. On the top right corner of the screen, a number of KPIs are displayed to indicate last model execution timestamp, the model convergence status, and the watchdog of online system. The trend chart displays the built-in watchdog tag from the Aspen Online project, which indicates the online system health. The watchdog value is initially set as 20 and decreased by a value of 1 every minute during the model execution. As soon as the new model execution starts, the watchdog value is reinitialized back to 20. As a result, with this zigzag type of a watchdog chart, it indicates the model continues to converge well in the past. If the watchdog line becomes flat within a certain period of time and did not recover, it indicates the model execution failed for some reasons and requires for further investigation. KPI screens again highlights indexes to be monitored closely by the operator, such as gas volume index, total condensate holdup in the pipeline, and hydrate formations tendencies. If any of these KPIs fall within the yellow or red range, it deserves attention from the plant operator for further investigation and proper actions. Pipeline profile screen shows 4 profiles of the main pipeline: pressure versus pipeline distance, temperature versus pipeline distance, total condensate holdup versus pipeline distance, and finally, gas volume index at the inlet of a gas plant in the next 9 hours. In summary, what has been shown in this video demonstrates on how to use calibrated HYSYS dynamic model, Aspen Online, IP21, and Aspen1 Process Explorer to create a real-time pipeline performance monitoring solution to help plant operator to visualize the pipeline operating conditions and the gas properties, predict the volume index of a final delivered gas in next 9 hours, estimate the hydrate formation tendencies, and more importantly, provide a predictive capability to plant operator to anticipate and respond to unplanned event in the plant operation to minimize the loss. To learn more about how to configure Aspen Online project, please visit AspenTech support website and download Aspen Online tutorials. Thank you for watching.